In this video, we are going to go over section 3.1, which is the constant e function, exponential function, and continuous compound interest application problem. Now, the goal in this section is to work on and be familiar with the exponential e function, and then apply the e with the compound interest problem. Now, there are two definitions regarding e. E is just very special number, kind of like pi. When we deal with the pi, this is about 3.1 for irrational number and keeps on going. Same thing, e is a special number about 2.71 and then it keeps going. Now, how do they come up with this e function? Well, that's actually coming from the limit definition. So the first limit definition, the number e can be expressed as limit as n approaches to 0 for the function 1 plus 1 over n raised to the nth power. Or similarly, you can rewrite, you see the same format, s is kind of like 1 over n, so you have n as a 1 over s. One of your homework problem ask you to explore the numerical value with this definition. So they will literally pick out a number n, like a big number, because n goes to infinity. And you're going to see that the whole function will approach to about 3.71. So I'm going to let you guys explore this definition in your homework problem. And then you'll see that the limit as n approaches to infinity, 1 plus 1 over n raised to the nth power will eventually be our e function value. Okay, so that's the two definition. You can write e as those limit definition. Now, one of the theorem is the compound interest formula. And then we use it kind of regularly too. Think about like saving money, right? And then or borrowing money, there's some interest and you want to know how long you're going to have to repay or how long you're going to get an interest when you invest something. So that's what we use. So the continuous compound interest formula is given as a is equal to p raised to a is equal to p, e raised to r and t. Each variable represent different value. So A represent a count at the end. So that's a final value, A. P is the initial value, principal. R represent rate. Some pay 5% interest rate. Some pays 10% interest rate, right? So R changes. Because it's a rate, we use it as a percentage. So when you plug it in, make sure you change to the decimal number. And then T is given by years. How many years are you going to invest the money? Or how many years do you have to repay? Now, some textbook use a different notation. On your homework, they use, instead of A and P, they use P sub 0 and then P, ERT, but it's the same thing. And then some problem, they use Q as a final value and then Q sub 0 as a initial value, but those are all same meaning. A, P, Q, they are all final value on the left. P sub 0 is Q sub 0, those are initial value. So let's take a look at number 1. Number 1 is just dealing with our first definition. You can see the similarity. A is equal to, so in this case, 700 will represent P. Looks like we have a E raised to 0.05. That's your R value. It's decimal as mentioned here because it's a rate. So you can say it's a 5% rate. And then we are given T value for different terms. So 3 years, 6 years, 9 years. And we are just going to be practicing just getting familiar with this formula. So how does it work? You literally want to find out the A. So the first one, t equals 3. Let's begin with the t equals 3. Then A will be 700. E raised to 0.053. And then we're going to use a calculator, nearest cent. That means 2 decimal place. you just have to literally plug it into the calculator, and let me pull out the calculator. Let's clear it. So 700 E function is in ln, but it's in the blue key, so you press the second key and then ln E, and we have 0.05. The first one was 3. So you end up having 813.28 because it's the nearest cent. So the first one, $813 and then 28. So that's what it is. We have a t equals 6, so same thing, just getting familiar with the formula and calculator. 700, plug it in, t for 6. This time it looks like you're putting the money into 6 years. So let's pull out the calculator. 700 E, raise it to 0.05 times 6 years. So that's 944.90. 944.90 final amount. Remember, A is the final amount at the end. So it makes sense. Longer that you put in, your interest will grow. T equals 9 years, so expecting a lot bigger than $944. So 700 E, raise it to 0.05, and then raise it to 9 years. So 700 E, raise it to 0.059. Okay. $1,970.82 rounding to the nearest cent. Okay, and that's it. Now, sometimes they may ask you to find out the t with a given. Sometimes they may ask you to find out the rate. Okay, so these variable can change. They can give you A, P, T, and then ask you to calculate R, or they can give you P and A and R, and then ask you to calculate T. So make sure you plug it into the correct function, correct variable for the value. So let's try a couple more practice problem. So these, again, you can see the same format follows, right? A is equal to P, E, R, T. This time 4 looks like A. There's no number, but you can always think of 1. So it looks like P is 1. R in this case is 0.07. This time you're solving for T. As I just said it, here you calculate A. You solve for A value. This time you're solving for T. And then number 3, you're solving for R. So it changes. Don't expect you're always solving for A. Okay, so let's solve. Okay. Now, here, one thing that I want you to recall, T is on the exponent. It's not a multiplication. So we have to somehow bring this power down. And that, recall from algebra, you apply the ln function for both. If you apply ln, one of the rule described that you can bring down the power in front, right? So one of the property on ln, the logarithms, is power. So recall, let me write it over here. Ln of x to the n is equivalent to n times ln x. Okay, so that's what I'm gonna do. I'm gonna apply ln both sides. So if I apply ln, so it will be ln 4. And then apply ln to the entire right hand side. Now by the rule property, you can bring down n in front to make it as a product. So power changes to product. So this whole thing changes to product And then now ln E is just 1. ln 4 is a number. So you really have 0.07t and then ln of 4. So to solve t, I divided by 0.0t, 0.07, 0.07. So t is equal to ln of 4 divided by 0.07. So let's use the calculator and then rounding to the 2 decimal place. ln of 4 divided by just what was it, 0.07, 0.07. Rounding to the 2 decimal place, it looks like I'm gonna have 19.80. 19.80 years, almost 20 years. Okay. So this time we use same formula as number 1, but we solve for letter T. So let's do similar problem and then work on number 3. Same formula, this time we're solving for R. Okay, so same thing. The problem is R is on the exponent, so I'm going to apply the natural log both sides to bring down the exponent as a product. ln 7. So this whole thing comes down as one of the properties. So 3R times ln E. ln E is just 1. So we have ln of 7, just irrational number, equal to 3R divided by 3. So R end up being ln over 3. Now if you put that on the calculator, you have ln 7 divided by 3. ln 7 divided by 3. You have 0.6486. Now here, we have to be careful. Yes, this was a 0.6486 and then really long decimal. But remember, R was rate, right? So rate is a percentage. So this will be equivalent to 64.86%, rounding to the 2 decimal place. Don't forget, rate is unit is a percent, so you wanna move 2 decimal to the right to make a percentage. And because they want you to round it to the 2 decimal place, that's why initially I took 4 decimal place. Okay, so these are pretty simple formula. Now the remaining problem, we have 2 problems, 4A and B, and then 5. We are going to be using these formulas to solve the application problem. So number 4, we have some compounded continuously problem. And then number 5 looks very similar to your homework problem. I, in fact, got it from your homework number 11. Using the same formula, the compound continuously. Okay, so let's take a look at a couple things. Number four, Bank A offers a 3-year CD that earns 2.05% compounded continuously. So we have already a couple information. 3 years for 2.05. If 5,000 were invested in this CD, how much? So that's the key point. How much? We are talking about money worth in 5 years. Okay, so let's take a formula. A equals PERT. What are something that we know? Well, I'm investing 5,000, so that's my initial money. So that's your P value. So I'm given P as 5,000. And looks like I have 2.05 as my R, 2.05%. So that's going to be 0.0205, right? 2 decimal to the left to make a decimal value. So we got all these. Now, how much will it be worth? That's like final amount. So I want to look at A at the end, right? A at the end. Oh, I'm sorry. I think there's a slight typo. This should be 3 years. Sorry. It has to be match up 3 year because bank only offers 3-year CD. So that's a typo. So T will be 3 years. How much will I get? So I invest 5,000. I'm getting interest rate of 2.05% compound continuously if I put that money into 3 years. So I want to know at the end of 3-year period what my final investment value is. So you're expecting more than 5,000, correct? So that's what I'm expecting. All right, let's plug it in. We did this problem very similar. We had a problem that involves A, finding out the A. So it's gonna look very similar to number 1. So A is one that I want. 5,000, your initial money. E, raise it to 0.0205 for 3 years. Okay, now this is very easy on. I do not have to apply ln because this is all plug it in. No variable to solve. So I'm gonna literally put the whole thing into a calculator. So let me pull that out. It was 5,000 E, raise it to 0.0205 for 3 years. Okay. Looks good. I am getting more than 5,000 and this is money, so I'll round it to the 2 decimal place. So it looks like at the end 5,000 will be 5,000 initially started, but at the end it will be $5,317.15. Okay. $5,317.15 at the end after 3 years. Okay. Let's try letter B. How long it will take. This time I'm looking for T. So I'm going to be taking the same information. Initial money is still the same. Rate, it doesn't change. So 5,000 to begin. Let me in fact copy these two. Copy. Okay, so these are what we already know. How long? Oops. Okay. How long is what I'm trying to find? So we have A value and then T. Okay. And T is something in question that we have to figure out. And we want to know how long it will take at the end towards 10,000. So it's like doubling money, right? 10,000. Okay. Your initial 5,000 doesn't change. You want it to be 10,000. Then how long do I have to invest? Well, let's copy down the formula. A is equal to P, E, raise it to R and T. My final amount is 10,000. I want to be 10,000 with starting money P 5,000. And then E, raise it to the same rate, 0.0205. And then T is the question. I don't know how long it will take. So you can see that this to me looks very similar to number 2 where we had to figure out T. So I need to apply ln both sides. Bring down the power as a product and solve for T. So that's the exact same approach I'm going to do. I'm going to apply ln both sides. So ln of 10,000 and then ln of 5. Oh, let me do a little trick. Before we do that, I'm gonna make the number simple because these are large number. So I'm going to divide it by 5,000 because this is just product. So that way we are dealing with a smaller number. So this is 2, 5,000 goes into 10,000 twice. So 2 is equal to e raise it to 0.0205t. Then I'm going to apply ln. So now you have ln of 2 equal to 0.0205t times ln of e. Okay. So far so good. I did very similar approach as I did on number 3. I apply the ln. Resize. Yes. So we can bring down the exponent into a product. Now at this point, ln e is just 1. To have t by itself, I'm going to divide it by 0.0205. Divided by 0.0205. So my t is equal to ln of 2 divided by 0.0205. So let's put that into a calculator. ln of 2 divided by 0.0205. Ooh, looks like it's gonna take 33 years, almost like 34 years to double that money. Okay. So t is 33.81 years. So looks like it will take approximately 33.81 years to double in value. Okay. All right. Last exercise, and this is number 11 of your homework. Okay. We did a lot of growing. Let's say this time we want to do the decay, which means getting rid of, not doubling, but reducing down in size. A radioactive element decays according to the function Q equals Q sub 0 E raised to the RT. Now this formula is not so much different than A is equal to PERT. Q is like your final size. Q sub 0 is your initial value, and then you have E raised to the RT. So just because it looks like a different letter, don't treat it as a different formula. It's the same formula. They just use different variable. Instead of A, they use Q. Instead of P, they use Q sub 0. So they also define Q sub 0. Q sub 0 is the amount substance at time 0. So that means 0 right at the moment. R is the compound rate, just like we did R as a rate of interest. T is time in years. Q is the amount substance at time t. So if it's time 10, that means 10 years later, so the final amount. So they also give you the compound rate as a negative 0.000385. Notice that this time your R value is a negative. So that's another observation that you can make. Earlier we had R as a positive here. 2.05, 0.0205. So that means your final amount will grow. Here you have a R as a negative, so that means your final amount, whatever the beginning amount that you have, you're going to have the final amount reduced because of a negative. Here's the main question. How long will it take? So I am asked to find T. How long will it take? These are something that you want to do. Take a note of everything what they give you. How long will it take certain amount of element to decay to the half of its original amount? So here's the key word. Whatever the original amount, I want half of it to reduce. So very similar to letter B, we did practice solving T. Okay, let's see if we can figure out all these variables. So remember, Q is the final amount. And then Q sub 0 is the initial amount. Okay. And then R is given. That's an easy one. Negative 0.000 385. You do not have to change this one into decimal because it's already given. It's not percentage. It's given as a decimal value. All right. What else? Here is where you have to decide Q and Q sub 0. Whatever the original amount was, at the end, you want half of it. So let's kind of do the labeling, right? You want final amount to be half of initial amount. So you can say Q is half of Q sub 0, right? Q sub 0, right? Whatever Q sub 0 initial amount is, final is half of Q sub 0. So that's what I'm going to put. Q will be half of Q sub 0. Q sub 0, I don't know what original amount is, so just leave it as Q sub 0. E, raise it to negative 0.000385 T. These are the tricks that I want you to use. They didn't give you a particular amount, but they give you enough information to use it. So I don't know what initial amount is, so I just leave it as Q sub 0. But I know final amount is half of original amount, so that's half of Q0, and that's what I did. Similarly, what I did here, I divided by 5,000 on both sides to get rid of it. So same thing, I'm gonna divide Q sub 0, Q sub 0, and that's nice because this divides perfectly, this get canceled. Half is the same thing as 0.5, so all I have is 0.5 left over here. E, raise it to negative 0.000385 T. 385T. Now, what did I do afterwards? I apply ln to move the exponent down as a product. So that's what I'm gonna do too. Apply ln both sides. ln of 0.5, ln of E, raise it to negative 0.000385 T. Okay. By the property, we can move the exponent down to a product. So ln of 0.5, negative 0.000385 T times ln E. ln E is just 1. So to have T by itself, I'm going to divide it by negative 0.000385 divided by negative 0.000385. So T is equal to, let's do that. What is it? Negative 0.000385. Okay, so ln 0.5 divided by negative 0.00385. So it takes 1,800 years for that radioactive to decay its half amount. Okay. Typically, when something decays, like a trash, right, it takes years. So it makes sense it takes a large amount of time. So I just rounded to the nearest to here on the MyMathLab, it's asking you to round it to the nearest year. So whole number 1800. So that will be my final year, 1800. Now, notice that I didn't do any rounding until the end. That's what they want you to do. Do not round until final answer. So ln 5 is a decimal, but I didn't round it. I just left it as ln 0.5. Because if you start rounding too much, your final answer will go off. So any rounding, leave it at the last step. Okay, so this is pretty short section. dealing with just two things, definition of E, and then one formula to explore the compound interest and decay formula. Okay, on the next video, we will move on to 3.2.